Okay, so welcome to our lab 4 on data visualization. We've covered the important data structures in Python. We started our journey from basic data structures such as a list, a dictionary, a tuple, as well as a set as the 4 basic data structures. And we also saw how we can use the files and maybe load our data from files to these data structures such as a list, and probably do some little bit of aggregations or analysis on that particular data that has been loaded from a file. But later, we're introduced to more advanced data structures. These included NumPy, which forms a very basic advanced data structure for data analysis. Most of the tasks that we are going to be maybe carrying out in data science and data analysis, maybe the data is much or is presented in NumPy for easy analysis. So apart from NumPy, we also went into another package called the Pandas, and under Pandas, we were introduced to 2 data structures. The first one being series and another one being data frame. So today we are going through data visualization. We just want to show you that Python has got different ways how we can do data visualization. We are not going to demonstrate all of them, but just some packages that you can use to visualize your data. And you can explore others, but I think the packages that are to be presented in this presentation should be enough to help you visualize your data in many cases. So we are going to go through data visualization using 2 popular libraries. These are matplotlib and Seaborn. And of course, we are also going to see how we can do the visualization directly on the Pandas structure. That is something like maybe a series or a data frame. How we can create a chart directly from there without necessarily maybe importing matplotlib or a Seaborn. But matplotlib will be very important if we want to add more maybe ways or attributes to our visual element like a chart. And a Seaborn, which was created based on matplotlib, extends the functionality of matplotlib with even better ways or other options that are not available in the basic matplotlib library. But as I said, there are many other data visualization packages in Python apart from this. So we needed to create, or why do we create visuals? We've seen that before we're able to present our data as a structure, and from those structures we're able to do some analysis. So we could do maybe summarize our data into a table. Maybe we could summarize our data into maybe, for example, cells per category, and we are able to get some information, or maybe to get average cells per category or something like that. But for people interpreting maybe data that has been summarized in a table is not very it's not their primary way of processing data. It's not easy to determine maybe the relationship of that data, or to determine some patterns in our data by just looking at a tabular representation of our data. But if we are to visualize that data, it helps us identify some patterns that could not be identified if we just presented it as maybe a collection of numbers or just as a table. So we are here presenting different charts that will help us identify such patterns through visual representation. And Here we just listed some of the charts that are common that we may use, like a bar chart, a pie chart. Bar chart is one common visualization element, and we have pie chart and the histogram. So bar chart, and the histogram, you can use them if you want to maybe visualize what we call univariate data. So you can have a data which is just representing one column or maybe one variable, and you want to visualize that. So you can use a bar chart to do such kind of visualization, or maybe a pie chart, or maybe a histogram would also do that. Sometimes you can even use you can also use a box plot if you want to see the distribution of that data, and probably even to identify if that data has got some outliers. But you can also represent maybe bivariate data, like that which involves two variables, using other charts like a line chart, where you have maybe two variables and you would want to compare how the two variables maybe are related, maybe increase in one variable, what is an effect on the other variable, maybe x and y. And of course you can also use the scatter plot and the other charts that are out there. So we are going to demonstrate how you can use the packages, especially matplotlib, using some basic charts that we have here, such as a bar chart, maybe pie chart, and a line graph or a line chart. Then you can extend that knowledge to experiment other data visualization charts that are available in these packages. So as always, we need to import necessary packages. Like in our case here, the most important package will be a matplotlib, because we're going to use that again and again. And in a matplotlib, there is a sub package. So we have matplotlib module, and inside of that we have a sub module that we are going to use, or that provides us with the most functions that we use for creating different charts. So we call it pyplot. So we are importing it as a PLT. So whenever we have PLT, it means we are talking of a package or sub package from matplotlib called the pyplot. We also have a seaborn, which is based on the matplotlib, and we will see how we can create some charts using this. Then we have our two usual friends, pandas and numpy. We are going to see that although there are many different libraries for creating charts, but in some way their interfaces are somehow similar. So how we create charts using Seaborn, and maybe how we specify their attributes, will not be so much different from how you use maybe a vanilla matplotlib library. There are just some little differences that we need to take into account when we're going from one library to the other. But these libraries, because they are created based on each other, like in this case Seaborn was created based on matplotlib, at the end we find that the two libraries are too compatible, and you can use them in the simple or in the single chart. You can combine functionalities from Seaborn and functionalities from matplotlib in a single chart. So let's see by first of all importing our dataset, the first dataset that we're going to use to demonstrate our charting. We are going to use Atlas cells. I don't have that one here, so let me import that one. But as we're waiting to have it, we have demonstrated that in that particular Atlas cells we have this data, retailer year, state, product, and the total sales presented in this manner. So for the year column, we have only 2 years, 2020 and 2021, and of course a number of retailers, a number of states, and number of products. Okay, so we did our importation, and we have our data loaded. You can explore that, but we already did that, so we'll not talk much about our data set. It's the same data set that we've been using in the previous labs, especially I think lab number 2 and 1. Okay, so our first data visualization that we are creating here, we are creating directly on our dataset. We are not using libraries like matplotlib directly, but we are doing it directly on a dataset. Remember what we are doing here, we are just grouping our data. We have our data and we are only looking for data that satisfies the following maybe grouping criteria. So we are grouping by a retailer. So we want to have our data grouped by retailer on total sales. And if we do that, and of course sort our data, this is what we are ending up having. If I can take it here and do the grouping before we do anything, our data is first of all grouped as follows. So we have the following retailers, and these are their corresponding sales. So that's what the grouping is doing. Then after the grouping, we've kept such data, this structure above, in what we call DF cells. Now we can plot here. We can plot directly, but sometimes if you don't want even to keep it in a variable like that, you can do your cropping immediately after doing the grouping. Of course, we've added the sorting here just to make sure that our data set is in a sorted manner. But if you don't want it to sort it, you can also omit this part. But let's assume we want it to be sorted. At the end of this one, you can just add the plot. And of course, the beauty about Colab is that it is able to suggest some code for you according to the context. So this is a code that has been suggested for me. It is suggesting maybe I want to create a bar chart, and it has suggested a color that I should use for the bars, and probably using some matplotlib, it has suggested some of the things that I can add. But down here, I'm not yet using matplotlib. All these things like specifying a title, a label, etc. I'm doing them directly in a plot function here. So let's go and see that. So we can see that from our data frame, we can choose to plot something from there. So we are saying df sales.pilot. Of course, this is a data frame, but generally it's a series because we have filtered only one field, which is the total sales. So the type of the bar chart that I want to create is a type of chart that I want to create is a bar chart, and this is a horizontal bar chart. If I just have a bar like this, it will create a normal vertical bar chart, like a column bar chart, but this one is a horizontal. I'm specifying the size of my chart in terms of width and height, and you can of course omit this. It will create a default size for you. The title for my chart and everything. So if I run it according to the specifications that I've given there, I can see that the title of my chart is here, and it is using indeed the data that is equivalent of this, because that's the summarization of my data. The first part here is doing that summarization. then we are plotting. So it is able to take these things. These indices are becoming our labels here, and this is a side for the cells. So our cells, I think they go into millions, and by default it has presented our data in this format, and it is saying it is presented in something like maybe 2 million or some maybe tens of millions in this presentation of our data. But instead of having our data like this, or our maybe horizontal bar like this, we can scale it in a way that should be more readable to our users for easy interpretation. We are going to see that later. So this is one way of how you can create a chart. We didn't use any matplotlib directory here. We just used our data frame and plotted a chart from there. But we can also achieve the same in this manner. Of course, plotting directly on the data frame or on the series, pandas series, and specify the other attributes using matplotlib. So we've just created a simple one here. If, for example, I take this and maybe put it here and run it, it's going to create a simple chart for me, but this chart is missing some important things. It has no title. So as we saw, we can specify titles inside here. Apart from kind and color, we can try to put other things like title equals etc. But here we are demonstrating something different to say you can mix it with the matplotlib and specify the other details using matplotlib. In this case, the title, X label and Y label have been specified using a matplotlib. And if we are to run this one, we are going to get something similar as before. That's our title, but this title was specified using matplotlib, and we have this Y label and X label. They've also been specified using matplotlib. So it's up to you. It's a choice. If you want to come up with a bar chart or something similar, you can plot directly on your series data, or you can use even matplotlib and mix it with the plotted chart to customize its labels or other things, maybe label colors and anything else. Another way, as I said, this one is not looking so nice. It might not be very good for someone to interpret what these numbers are representing. So this is just because our numbers are too big. They are in millions or thousands, maybe hundreds of thousands. Then it's better for us to scale them down. So there are many ways you can do that, but here we're just trying to show you that as you are summarizing your data, your summarized data, you may wish to reduce the numbers here by dividing them by 1000. So it's like each value is divided by 1000. We are having a sum and dividing by 1000, something that we learned before about broadcasting. So this 1000 will be applicable to each sum for each retailer, and these values are actually division of 1000. If we are to check, this one is 74,000, but if we don't divide by 1000, okay, sorry, what did I do? If we don't divide by 1000, we are going to end up with big numbers. So it's something like, is it 74 million? So they are very big numbers. But we can scale them down, maybe in 10,000 or maybe in 1,000 scale, like that. So if we do that, we have better smaller numbers that we can easily represent in our maybe charts. And here we have something that will be more legible. You can even choose to scale it down even further. Just remember that after doing that, your data should be descriptive enough, or the label on the x-axis should be descriptive enough to show that these numbers are in actually multiples of 1,000. In other words, someone should multiply them with 1,000 to get the actual value. So this is shown as 50,000, but in actual sense, this is 50 million if you are multiplying it by 1,000. So that's how you can represent your data, or you can correct the scaling issues that we have there. You can manually do it like that. And we are now showing you how you can do the plotting, but using matplotlib. So we've shown you how to use the a plot function on a series data structure, but down here we are saying sometimes you can also use matplotlib to do your chart. So the function that we use for horizontal bar chart is bar h. If you just have bar, it means it will be a vertical bar chart, but we want something as before, so bar h, and you specify that which should appear for the y-axis and that which should appear for x-axis. So from summarized data that you have, we have that summarized data here. We summarized our data and we already divided by 1,000. So this summarized data equivalent to this one, we needed to specify that these labels or these indices will represent y-axis, and these values are the ones that will represent x-axis. So that function will need that two parts of information. So we are saying retailer.index. So these are labels, these ones. And the second attribute is retailer.values. So they'll be the cells themselves, and you are specifying the color here. Apart from that, the rest of the items are as before. We are specifying the title, the X label, and Y label. And if we are to run this, we'll get something similar. So just to take you back, we are doing these things like sorting. The aim of that is just to make sure that our data is okay, let's remove this one. It's just to make sure that our data or our data bars are represented or are given to us in this manner. It makes our data easy, or our chart easy to interpret, because you are coming from categories that have many points or many cells to categories that are having maybe very little cells. If we don't do that, we may end up having a combination of things like that. So it's not really good looking, and sometimes difficult to compare or to know which one is the highest seller here and which one is the next highest seller. But if you sort your data, such interpretation becomes so easy. You are able to know that West Gear was the highest seller, and it was followed by Foot Locker, because your data was already sorted. Okay, so we've shown you how you can use a matplotlib. We can also use a Seaborn, another package. So as I said, it's all about your choice, and sometimes, of course, we may be looking for the features that are more specific to those other libraries, but it's all about your choice. But here we're just trying to show you that you can also achieve the same apart from directly plotting on the data frame or data series, or pandas series, or directly or plotting them using matplotlib. You can also use a seaborn package to do that. So we have our data, and of course we have reversed the sorting here. It was sorted before in ascending order, but with a seaborn, to have similar structures before, we needed to reverse the sorting. Let's first of all take off this to see why I have reversed the sorting here. So this is a seaborn, and for a seaborn we use the bar plot, and because a bar chart can be horizontal bar chart or vertical bar chart, and in a seaborn we don't have two functions. In matplotlib we have bar h specifically for horizontal, and we have bar for vertical bar chart. In seaborn we just have a bar plot. So because of that, we needed to specify what kind of bar chart we are looking for. Is it a horizontal or vertical? In this case we have h. Orient is equal to h. We are looking for horizontal bar chart, but it gets similar data. For example, we are getting literal dot values, which are dot values for x-axis, and y we are getting literal dot indices, which are labels from our summarized data, and we are specifying the color. And as we can see, we are also using matplotlib to specify other things like a title, x label, and y label. And if we run this, we'll get something similar to what we got. But our presentation now is starting with the least sellers to highest sellers. That's a seaborn. But to have something as before, to have first bars as the highest sellers, then we just need to put our data in descending order. So we have said ascending equals false here to reverse the sorting, because our data was sorted in ascending order. We are sorting them somewhere here in ascending order. So that data, pandas series structure, we've reversed the sorting criteria. Then it will give us something as before. So it's all up to you. Whichever you find easy to use, you can use that to plot your charts. So what if we don't want a bar chart? As I said, a bar chart, a pie chart, we use these ones for univariate data. So we are looking at visualizing one variable only. Like in this case, we are visualizing only one column of total sales. So we've grouped total sales by categories, and we have visualized that. But we can also present similar data using a pie chart. It's a single variable we are looking at. We just want a pie chart to show us the proportion proportion of maybe those retailers in terms of sales. So to create a pie chart, we are having a similar data. We are filtering the same data as before. I've just tried to use a different variable as compared to the one we were using before, but everything here is the same. So we have our data set, which in essence, we have this data set here, this one. So we want to plot a pie chart using that. So if you want to plot directly on that, we just use a plot, and you specify the kind to pi for pie chart. You can specify the size for the horizontal and vertical size here. So in our case, horizontal and vertical will be the same. Then this part you are specifying that the numbers or the percentages that are displayed, they should be displayed as what? Do you want them to be displayed as whole numbers or maybe to some decimal numbers? So here we've specified that we want them to be to 2 decimal places, but you can also remove these things if you don't want to include the 2 decimal places. Let's try to plot first and see what we are getting. So this is our chart. It is able to pick our structure from there and create a chart for us. And indeed, these are in 2 decimal places. You can choose, if you don't want 2 decimal places, you can choose to modify this one, maybe put 0 here, or just remove the dot part. Then if you put to 0 decimal places, you have something like this one, just integer values as representation of your slices for the chart. So a chart, a pie chart has got a variant which we call a donut chart. So it's a pie chart but with a hole on the center, or at the center here we have a hole. So our chart looks like a donut. So how do we make it a donut chart? We can see that up to here we are using similar attributes as before. We are using similar arguments, but now here we've added these 2. This one not necessarily only for the donut chart. No, this one you can also use it for basic pie chart. It's just trying us to say where should we start plotting the bars. So starting angle we put 90 degrees, but the part which is creating a donut chart is this last part, which is wedge props, and is given as a dictionary wedge props, and we've specified the width. So we've specified the width, and our width is 0.4. So you are specifying the width. So this number, the bigger you put this number, the bigger will be the hole. The smaller the number, the smaller the hole. So the numbers should range from 0 to 1. And there's another way of writing this one. Instead of having this one as this, you can put it as a proper dictionary. We are going to try that one. First of all, let's see our donut created. So this is our donut that has been created. We can choose to increase this maybe to 7. And if we put it to the width of 1, it means our radius, all those ones will meet at the center. If we put it to there, it will be equivalent of creating a pie chart. We are not leaving any hole. But if we decrease that value, so our radius will be smaller, maybe to something like 2, then our donut will have a very big hole like this. But I think putting it to somewhere around 0.5 or 4 is much better. It is making our donut to look better. Proportion of the hole and the colors are good. So as I said, instead of representing this one as this, because it's just a dictionary, and we know that a dictionary is created using something like this. So you can pass a dictionary directly here. Not these ones. You can pass a dictionary directly here, by specifying now width, you write it as follows, so 0.5. So this is another way of achieving the same. You put it as dictionary in that way. If we run it, we should get similar result. So you may see some maybe code, they are using this one instead of dict. That should not be an issue with you. It's actually the same thing of presenting your data. So those are two charts that you can use to visualize one variable. But we've used data from a data frame. We have a data frame, we are filtering it, and we are making a plot. And that can make us to think that the plotting of charts in Python, you need maybe a data frame. But this is not necessarily so. You can have your data in other data structures. It has not necessarily to be in a data frame. It can be just array of NumPy, or it can be array or maybe a list or something else, and you can use that one to plot a chart. Like in this section, we are trying to show you that you can do the same plotting or something similar, but the data is not coming from a data frame per se. You have your data coming from something else. In this case, we've created some dummy data, which is just array, one-dimensional array of cells. Then we have another one-dimensional array, which is showing corresponding retailers. So we have two arrays. You should remember that when we're creating our maybe a bar chart, we are passing two things. We are passing data for the x-axis, data for the y-axis. So those data you were passing are actually arrays. So you can have them separated like this one. Maybe you read from the file and you had it as an array, and you had another one as an array representing the y-axis, another one representing data for the x-axis. So you can create a chart like this, a bar chart. Then you specify what will be your y-axis, what will be your x-axis, and you can specify the color. If you don't put the color, for example, it's not a must that you should specify the color. If you don't put the color, it will create with a default color, which is blue. But sometimes you may want to specify the color to avoid having a default color like that. Then it will create for you a bar chart with the color specified. Before moving forward, this component of colors is very important. Up here, I've included a link in your lab. You can click this link, which will give you more names for the colors that you are looking for. It will be a good reference point for you for getting more names for your color names. So I hope it will open. Yes, so you can come here, you'll be able to find different color names which you can use. We've been using there like a pink, but you can also use the other colors like maybe black, etc. Sometimes instead of a name, you can even use the hexadecimal representation of that color. So you can pick this number starting with the hash. You can pick that number and put it there, so it will also work for you. For demonstration purposes, I don't know which color is good, but there are many names here of the color that you can choose from. Let's say violet. So you can choose to take the number or the name. It's all up to you. If we choose to take the number, violet. If you choose a name, we can say violet. So it will create this for you, or you can choose to put a number, which is hexadecimal number. That number represents a color as well. So it also create a color for you. So anything that you use will work for you. That's fine. Here we're also demonstrating that we can have our data represented as 2-dimension. So we are having a list inside here for a 2-dimension. It's just a array of literals and their corresponding cells. So your data can be, the point is your data can be represented in different ways. Apart from using pandas series, you can have your data in other data structures as well. Like in this case, you can have your data as a data frame. Then using whatever you know about, you can have your data as NumPy, and using the knowledge you know about NumPy, you can slice your data or get important areas from your data to create a chart. But it's all up to you. This is because your data will not always be maybe in pandas. So if you have your data like that, you can say, I want to create a bar chart, but I'll take that which is on the first indices, which is represented by categories or the retailers. That will be for my y-axis, and that which is on position index 1, so these are numbers, will be on my x-axis. But this one will be represented as the what we call, let me just take it, it will be represented as the let's see, we have sales data. If we run this one, our structure, if you see, there's no difference between this and that. It's all represented as a string. So these are numbers, but as we know that the arrays keep data of the same data type, so these are numbers. These are a string, a text. This is also a string, but we're supposed to have a string here and a number this on this other side. But because we don't have a number, we have the number represented as a string. Then when you are doing your plotting and you are looking for a number, then you need to convert the value to say, I want the value to be a number. So we are saying for those on indices 1, I want them to be treated as type of integer. So that's why we are doing this conversion. If we don't do that conversion, because it will not treat these ones as numbers, our chart might not be well represented. So we can see here our yes, everything is messed up. Or I don't know. Yeah, but let's try to show it that, please, these are integers. These are integers, and our chart will be now nice. The other one, we had 800 here, it was just messed up, but now this one is presenting our data much better because it has recognized that these are numbers and not just text data. But this said, it will be easy for you, or in most cases you are going to have your data in a data frame and you'll be doing visualization from the data frame. So probably you may not need to worry much about NumPy representing your data. But still more, because we are coming from the background of NumPy, you should know that your data can be represented in a NumPy, and you can take that one and use that to plot a chart. So for a pie, using the same information as above, you can just specify the x-axis or something equivalent to the data you're looking for, and also need to specify the labels. So we're saying we want the labels to come from index 0, and our actual values will come from index 1, and everything else as before. But because we want numbers, we've changed it to numbers. So this one will also create a chart for us, a pie chart in this case. Okay, so sometimes when you are creating a pie chart, you may want one slice, whether it's a pie chart or a donut chart, you may want maybe one slice, which is a slice of your emphasis to explode. So there is another attribute which we use here, explode, and you specify which part you want to explode. So this is a list that you provide with 0, 0, 0, 0, 0, 0. So we have 1, 2, 3, 4, 5 slices here. So each slice is represented by a number, which is 0. So we have 1, 2, 3, 4, 5 zeros. And if we are to, okay, let me take off this one. If we are to run this one, we can see that our chart is as before, because we've said each slice has got same explosion number, but exploding number we can specify that we want maybe a second chart to explode. So maybe we can give it 0.1 or 0.2. So if we do something like that, that one is going to explode. Maybe it's a slice that you wanted to put much emphasis on. It can be maybe a slice which is having the highest or the largest cells, and if your cells are already in ascending order or they're already sorted, then you can just specify the first one to be exploded. So here we are saying this one should be exploded. But apart from that, you can also choose maybe to have a shadow. You can have a shadow. And if we say a shadow to true, okay, we can also start having a starting point, no problem. So if you say shadow true, it will now make them look like 3D with some little bit of shadows here. And we are exploding this one. So we've said starting point for plotting is 90 degrees. So the first slice will be only 90 degrees. So we are plotting from here and we are going anti-clockwise. So the first slide is exploded. If we try to show that we are exploding the first slide, .1. So we can see we have changed now. We are not exploding this one, but this one as the first one. So the plotting, because we've said we are plotting from 90 degrees, it is showing that indeed we are starting from 90 degrees and we are going anti-clockwise, and we have just exploded it with 0.1. Okay, so we've shown you two charts that you can use for univariate data, a bar chart and a pie chart. You can do some modifications of these charts in terms of their appearances, maybe changing color and other things. I'm going to demonstrate how you can modify some of the chart elements attributes in the next few activities down here. But we want to take our attention away from a pie chart and a bar chart to something else. We're going to demonstrate how you can use maybe a line chart and something else for plotting our data. So a line chart will compare two variables. In most cases, we can have one variable on one end and another variable on the other end, and we can use a line chart to compare them to see how they are changing. So maybe an increase in one variable is resulting in maybe some increase in another. Maybe an increase in price is resulting in a decrease in the demand. or something like that. But in our case, we are going to start showing the line graph or line charts by just trying to show you the trend. So not worry much about comparing them with the second variable, but just to show trend. Many things that we may want to have a trend. We can have data that we get maybe on daily basis. These can be sales. Maybe we have sales on day 1, day 2, up to day 30 for a month. And we want to see how our sales were fluctuating on each day. Maybe today we made many sales, maybe tomorrow the sales were not very good, and on the other day maybe sales were picked up. So we can present such data using a line chart, and we are able to see the trend. So we are creating, because we don't have data for something like a month up there, we are trying to create some dummy data here using random. We are generating dummy data for 30 days. We want our data, so it's going to create 30 elements. We want our data to be sales between 15,000 and 20,000. So it will create sales between 15,000 and 20,000, but for 30 days. So that will be our dummy data. We can actually display it here just to see what it created for us. So it has created this data set for us. It's just an array, NumPy array, and these are sales. On day 1 we had this one. On day 2 of the month we had these sales, then 16, 18, etc, 16, 15 on day 29, and 18, 337 on the last day. So these are sales, and we can use this data to create a chart. So using that data, we can create a chart. Like in this case, we are saying plot. So matplotlib has got a plot. You should remember that we also had a plot, but we're using it directly on a pandas series. But we also have plot, but on a matplotlib. And this plot is a function that is used to create a line chart. You should remember, for a matplotlib, if you want to create a pie chart, use pie. If you want to create a bar chart, maybe a horizontal bar chart, you use the bar H. But to create a line chart, you use the plot. And we've specified the title, X label, and cells. So let's try to see what this one is going to show us. So it is showing us that our cells fluctuated like this for the month. So it's fluctuating like that. On 15th, our cells were below 16,000. We're between 15 and 16,000 somewhere here. But somewhere maybe on, it should be on 21, or somewhere on 18, or somewhere around there. Maybe on 17, our cells were close to 20,000. But we are able to see the pattern. So there are some important things here to note. Our chart, or our line chart, has got a different color, and the lines are dotted, and the points are also emphasized. We have like circles for the points. So all those are customizations that we've made in our presentation, or here while we're creating our chart. If I can take off this part and just specify the data that I want to use for creation of my line chart, this is what I'm getting. So that's the default chart. When you have not specified anything, your chart will be just like that. And in a case where you have so many data points, this can be trending. For example, if you maybe see data for the whole year, maybe you have 365 days, and you plot something like that, then it will be a trending lines that will show for the whole 1 year. And depending on how fluctuating your data is, your line can be very good in terms of trend, or it can show some trend that is having no pattern. But by putting something like this, it is able to give us this. So let's look at what these ones are actually doing. Of course, this is just emphasizing, this part is just emphasizing how thin or thick our lines should be. If I remove that, I think by default it is a bit thicker than that. So this is what we have. If I put something like 3, they should be becoming thicker. These lines, they are now becoming thicker, but not very good. We want them to be 1. That's better. Can we take it even further down? Let's see if we can have 0.5. So that's even much better. So you can choose, you can control how those lines should be. That's first one. But for easy for us to see, let's put it back to 1. So the second part, the second attribute that we've specified is this string. We have a string, and inside of it we have go dash dash. So there are 3 things here. We have the color. We call them we are calling them the color, the line, and the mark. So you specify those things in here. 3 things. So the G is for the color. You want your line to be clean. You can put red there. If I put R, everything the same, then it will create it with now red. I can put blue, B for blue, then it will create my chart with blue, something like that. So, and the order does not matter. You can start with something. So I started with the color. I may choose to end with the color. There are 3 things there. So maybe green. I can choose to end with the color. It will still be interpreted the same. So there are 3 things: the marker, line, and color. So this one dash dash is representing how this line should be. Is it a solid line, dashed line, etc. If I put only 1 dash there, then it will create solid line for me. But I wanted the dashed one, so I have dash dash. While this part is showing me the markers, these dots on the data points. So I'm using this one, but you can use others. For example, maybe let me try which one. I've given you a list of what you can use, some common ones here. So let me use maybe X. I can have X there. Then instead of a dot, they will be represented as the X's. So you can play around with that. You can try to change many things. And the same with these ones. We have listed them here to say you can use a single for continuous line, or you can use this, or you can use a combination of this and this, or any other thing. So let's try them and see what it means. You can use a combination of dash and a dot. Dash and a dot. Then you'll be having dash and a dot, dash and a dot, dash and a dot, like this. Or you can use the last one here, which is just colon. So you can use colon like this. That one will give you something like this, like dot, 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 dot. Okay, that's it. So that's how you can do the customization. These are very important things that you can use to customize your line chart there. And of course, you can also use them not only for line charts, you can also use them for other charts. Some of them are supported in other charts as well. You specify the color using these ones. If you want to emphasize the markers, you can also emphasize markers in other charts. So that's our line chart. So we are emphasizing here to say, let's see how we can change colors of the markers. Here we've created it and we specified our color to say blue, so everything was blue. But sometimes you may want to put emphasis on the markers. Maybe you want markers to have a different color. So we are saying, how can we do that? So we can use the MEC and MFC. These are two attributes that you can add when you are creating your plot. You can add MEC and MFC. They are to be used for specifying color. So C for color, and also here C for color. So we are saying we want mark edge color, or we want mark fill color. So each edge, or each mark has got the edge that surrounds it, and it has got the part which you can fill. For the X, maybe our demonstration might not be very good. So here we are also demonstrating using this one as before. So first of all, let me take off this. Let's take off this. And you can check here, we have done something here. Pink color, we don't have a proper representation of that one as abbreviation, which we can use here. It's not something that we can just put as P. So on this, I've just specified two things. I did not specify color, only line and the marker. So for the color, I've used a different attribute here to specify the color, because I'm using something that has no abbreviation that I could use directly here. So if I run this, this is what I'm getting. We can see that it's pink and everything else is pink. But now I want to isolate these ones. I don't want them to be pink. I want them to have different one, like hot pink in this case. So the edge colors should be hot pink. If I just specify edge colors, this is what I'm getting. So it will show, let me try to zoom one for you. So it will show that the edges of those markers have got hot pink. Its pink is different from the whole marker. Like inside the mark is a proper pink, but edges is different. Maybe it can be shown better if it is red. Let's see. So the edges are red. But we can also specify the fill color. So the fill color, mark fill color also pink, so that we show that as just one continuous color. Then we are going to have something like this. So you can use any color of your choice, but those are two attributes that you may want to use to emphasize points, and you may want to use different color from the lines. So on the points, we are specifying them using that. Sometimes you may have data from two periods. Maybe these are sales for the first quarter of the year in 2024, and also have sales for the first quarter of the year in 2023. You want to plot the two on the same chart to compare, two line charts to compare. Like in this case, we are having data for June 2024, dummy data, and we would want to create another dummy data for June 2023 and compare them. So here we are generating dummy data for 30 days as well, but for 2023, and dummy data for 30 days for 2024. So let's assume we have sales for this year, sales for last year, and we would want to plot them on one chart and compare. So here, okay, let's generate this one first. Here, for you to do that, you just need to plot, to specify both of them on the same by doing what we've done here. Then our Python knows that we should draw them on the same canvas, so on the same figure. So this is for one data. So this is data for 2023, and here we are also plotting for another data. So the matplotlib knows that all these things, because they are in the same space, we should plot them under the same figure. So for 2024, they are in hot pink, and for 2023, they are in green. So you can use full word here, green, it's okay, or you can just use the G, it's okay. Or you can even remove this one because that one has got abbreviation. So you can even use that one directly here to say as we did before. Then this one can go. So that's also okay. So the edge is blue and the other one blue, but for the other one ABCD. So these are sales for 2023 June and 2024 June. And because they're in the same space, they'll be created on the same chart and you'll be able to compare them. So these are just randomly generated numbers, but if you have proper data, you'll be able to see the trend, whether your sales dropped in this year as compared to the previous year or something like that. We are using here, of course, the 30-day sales, but it would be more sensible maybe to plot data for the whole year, 12 months. Maybe you have a single value for January, February, or to December for 2024, and you have similar data for 2023. If you plot them, you will see which months you performed better in 2024 and which months you performed better in terms of sales in 2023. Something like that. So that's it. Or you can try to have for the whole year. Let's try for the whole year. We can just regenerate this data. I will just maintain everything, but just regenerate this data. Let's regenerate the data for 2023, the whole of 2023, 365 days, assuming we are making sales on each day. And this one also 365 days. Then we can plot our chart. So if we plot, we have many points. Where is the limit coming from? These are not 300 something. What did I do? What did I do? Oh, I didn't run the plotting again. Okay, let's run the plotting again. The chart is just too small to have that one, and because they are too fluctuating, it's a random data, so it's not showing nicely. But if it were proper data, maybe the other one would be trending somewhere like there and another one somewhere down here without many issues. Yes.
I think it would be proper if we just add, we have summations of sales in January, February, December.
Just to have 12 points instead of 300 something points.
Yes.
Yeah, I think that would give us a better summary. So let's assume our data, okay, we can use the same range, but let's assume we have only 12 for each. So that will only give us for January to December. Of course, we have not changed the we have not changed the labels down here, but just assume it's coming from January to December. So it will give you some picture to say in January we made some good sales, maybe in this month some good sales or not good sales. But we can see that because we have two plots, we made sure that we should have the caption included here. So the reagent has been specified here. We are saying we are going to use a reagent, and our reagent is June 2023 and June 2024. If it's for the whole year, then you can just say the reagent, this will represent 2023 and the other one will represent 2024. So we are using that reagent. So you can add reagent not only to line chart, you can add reagent to a bar chart, to pie chart, and any other chart. So you can add it using matplotlib in this way. You specify your reagents using a list, like in this manner. Okay, let's take it back to where we were before. We're using some data of 30 days. We're using some data of 30 days. In June, we had something like that. Okay, so sometimes you may also want to change the labels and the title. Maybe we are just using line chart, but these things are applicable to another chart. You should take note of that. So sometimes you may want to change the label and title and even font, maybe for this one, maybe for this one, and for these ones. So here we are creating first font. We use a font dictionary. So this dictionary, you can write that directly into your title or wherever you want to apply that. But in this case, we've just defined them into a variable so that we can use a variable later. So we are specifying the family of the font, the color, etc. If you want to use the default family, then you may not include the family. You can just include maybe the color and maybe the size, etc. So this one, and the other one we've even included that our color, we want our color to be dark red, not just red. So we have this one as one of the named colors from the list that I showed you. And the size is a little bit bigger, so you can specify the size. Okay, so when you have plotted your graph, then when you are putting your title, you can put font dictionary at the end. And if you are also the same, applies when you are specifying your X label and Y label, you can put the font dictionary. So here we are using font dictionary 1 for the title, and the other one we are using them for the labels. But for the labels we have a bigger, okay, 15, for the title 20, that's fine. Maybe, and before we go there, if you want, you can also include the grid, but let's take off grid for now. That one is a different demonstration. So you are able to change here, you are able to change here. I don't know if I've used a very attractive color for the title. I don't know. I doubt. Magenta is not very emo. Magenta is not cyan. Maybe C. Maybe okay. But anyway, you can change anything here. You can put anything. If you like nature, you can put green or G. Then you can have your color like that. But let me go back to magenta. And okay, so that's it. And of course, you can also have subplots. You can have subplots That is to say, you can have plots that are plotted maybe side by side on the same figure, multiple plots. Maybe you want two plots, one to the left and another one to the right, but as a single figure on the single covers. Or maybe you have 3 or 4 plots which you want. Maybe 2 should take the first row and the other 2 should take the second row. You can do that using a subplotting in matplotlib. So we are making assumption that we already have the first data, and here we are creating data set 2 for our cells. So we have cells data somewhere, and we are creating data set 2 here. So we have 2 data sets. We want to compare them. Maybe we want to create bar charts, and they should be side by side. So using a subplot, you create your grid here. Before I come here, I think I had taken off grid up here. If you use grid, let me take you back here. If you use grid, that one creates grid. Sometimes you may want maybe your plot to show grids like those ones. So that's what this line is showing. You can use that one to any bar chart, whatever. You can specify if you want to show the grids and specify how small the grid should be. Maybe 0.3 if you want the lines of the grid to be really small. So sometimes you may be interested to specify grids for your chart. So we just included it there to demonstrate that. Let's go back to where we are. So you create a grid like this, and this one is creating the number of rows and the number of columns. So we have this one indicating the number of rows. So we just want one row, but on each row we want two figures or 2 columns, to have 2 columns. So we've specified that the first position should be taken by whatever we are drawing just immediately after it. So we've specified 1, so that is the first item. So on the first row we have 2 columns. Then on the first cell we are putting whatever we are doing here. So we are plotting cells that we've created here, which is cells data 2. We are creating it there, and we are doing whatever. Then we are creating another chart because it's the same. So we need to maintain the first 2 numbers. It has got first row, 2 columns, and now on position number 2 we are drawing this guy. If we had 3 columns, if we had 3 here and 3 here, then we would be able to create another chart, and that would have given it position number 3. So it means all the 3 charts would be on the same row, but here we only have 2. So only row number 1, only 2, on 1 and 2. So we are specifying something here using cells data. And if we run this one, then we are going to have our chart like this. So we have 2 charts, this one and this one. Did we not specify the size good enough? Why are we having our charts? Okay, better. So we have this one and this one, so side by side, and each of them have got their own titles. We should take note of that. We specified the title for the first chart and the title for the second chart, and we've also specified title for the whole chart. So sup title for super title, we have specified a title for the whole chart. So for the whole figure we have this one. If they were all maybe line charts, maybe they're just comparing 2 periods or 2 companies, and you don't want to put them in the same in the same maybe chart. Maybe this was a bar chart for the sales for company A and another bar chart for company B. Maybe you do just maybe say company A or company B, or if it's from the same company etc, you may wish to take off these titles and just have one big title which is representing both. So you may wish not to include these titles and just include that title. But in this case, because there are different scenarios, we have specific titles for each scenario. But these things, it's all up to you. You can take them off. You can also take this title off, and we only have one title remaining, which is the main title. Okay, so that's it. Those are the main things that we wanted to let you know, but maybe just in passing as we are closing, there are also other charts that you can consider, like a scatter plots. Scatter plots are good to compare also relationship. You can do that with a maybe a line chart having two variables, but you can compare maybe relationships in terms of whether the increase in one has got effect in the other, also using a scatter plot. Instead of using a trending line, you can use a scatter plot as well. So scatter plot will just plot your points for the two variables on your XY plane. Then from there you can see whether the trend is going down or the trend is going up. So but let's see if there's an important data we can use to demonstrate something here. Okay, no. Okay, so maybe what I'll do before we go to scatter plot, I'll try to just end with the we don't have a better data, but you can try to use data from Xcode data, which you need to clean it up, and you can try to use it to do the scatter plot. But I wanted to see something else. Okay, let me try to load that data, and I can demonstrate maybe one thing from there before our time is over. Do I have that data set here? Okay. Okay, so our data, of course, is trimmed. It's not a good representation of what we want to do, but in the project that you're going to have, you're going to work with the Xcode data that I'm going to give you for your own analysis as your final project. So you are going to have Xcode data for the properties, similar to what we are doing with the Brazil properties or real properties. Then you're going to answer questions from there. But here I just wanted to demonstrate something small. So it's just a small data set that I've included or I've shared with you. And our data set, we have 4628 entries, 4628, and we can see that for the price approximate USD, we have some narrow values. It's less than 4628, and the same for the surface covered in whatever they are less than. So our data is not very clean. We have to clean it first. But our data is looking like this. You can see that there is a narrow value here. So we need to clean them first. So let's first of all drop all of them that have got narrow values. That's what we are doing here. And we're also dropping this column unnamed 0. We don't need that column, so we are dropping it here. We are dropping column on index number 0 here. It's being dropped, so we don't have that column. And now all our data have got the same numbers here. no null values, and indeed that column is gone. So this is our data. We are trying to see, so these are prices, and these are service, the square meters. Sometimes we may want to compare, only that our data is combining so many things. We may wish maybe to filter for a specific type and check using a scatter plot for that particular specific type of data. So let me see, for example, first of all, just to explore what this data has. We can try to check if this data has got some outliers in terms of maybe property prices. One way to do so is to create what we call a box plot. We want a box plot for the prices, not this one, but price approximate USD. So let's see what box plot is going to give us. Okay, so let me suppress these things. Let's see our box plot, and our box plot shows that our data is really not representative. There are many data items that are outside our scope. We have some points even as far as here, outside our points. Just to give you a simple description of how we can demonstrate a box plot, let me try to create a small box plot from data that we've been using here, just to make sure that it makes sense for us. I'll try to create a box plot for these small cells that we have here. Let me try to create a box plot here. plt.boxplot. We want for this one. Yeah, so a box plot is something that looks like this. So it shows the distribution of your data. Like in this case, it has plotted a distribution of my data, and it will tell me if there are any data points that are outside maybe here as maybe an outlier. For example, in this data, our data is from 8,000 to somewhere around 15,000, but let me assume that maybe this one is 150. Oh, that was 5,000. Let's assume this one now is 150,000. I'll run that one again. Okay, my box plot is above. Which data am I using? Okay, now we can try to run this one again and see if it will give me an outlier. Okay, so we can see now that this is our box plot. It's saying almost all our data is here, but there's one data which is outside this box plot range. So that point is an outlier. That point that has been plotted there is an outlier. It's outside the box plot figure. So that is an outlier. But if our data has no outliers, as before, let's run it again as before and interpret what that box plot means. So this one has no outliers, but there are many important things. What it shows, this big box shows that, or indicates that this lower part is what we call lower quartile or Q1, and this upper part is Q3, upper quartile. So from this point to this point down here, that is showing interquartile range for that one, Q1 or Q3 minus Q1. So that's interquartile range. So this box shows that 50% of our data, 50% of our data set is in the range of these values. So maybe above 6,000 and below 12,000 or somewhere around 12,000. That range, 50% of our or half of our data points are in that range. That's what this one is telling us. And this other side to the end of our box plot and this one to the end of our box plot, from here going up to the end here, shows that 25% of our data is in this region. 25% is in this region. It's just below 6,000 or somewhere there. And another 25% of our data is above there. So if we can look at the lengths of this one, we can see that 25% of the data is sparsely maybe distributed there. But down here, 25% of the data are close to each other, as shown by a small whisker. We call them whiskers. A small whisker, down whisker here, or as shown by this upper whisker up there. So this one is longer. It means the data is spread, while this one is dense. I mean it's shorter. Our data is dense. So 25% is below here. 25% of our data is above there, and 50% of our data is just around these points. While this line that we see here, this one is a median, so more or less like an average or the middle point. So this is a median, so it will give you the median, or half of your data. Is cutting your data into two, so half of your data from there going down and another half of your data from there going up. So we can see that half of our data is below 8,000. So most of our data is below 8,000 and just little points are above 8,000, something like that. So that's how you can interpret a box plot. It's another good way of visualizing our data, and it helps us identify the outliers. As we saw, if there were points that are outside this, for example, if there were points that are considered outliers, a box plot will consider a point to be outlier if it is outside these whiskers. So if we have any point outside these whiskers, those will be outliers. So we can see that for our box plot here, using the data that we loaded from Mexico real estate, we have so many points plotted, because if there's no outliers, our box plot should not have points plotted. But we can see there are so many data points, which means our data is not normally distributed. Our data has got outliers, because without outliers, our data was supposed to have, this is a lower whisk and this is the upper whisk, and this is our box. It's just a very small box, our box here. So 50% of our data are just in this range. It's a very small range, 50% of our data, and 25% are up to here, and another 25% down here. It's very short whisker down there. So this data that we are visualizing here is really not too representative, especially because we have so many points. There are many points here. They are overlapping. That's why it's showing black. But there are many points. They were supposed to be showing like this, but many points that are outliers. So it means there are properties that have that are way above. Many properties that are way above in terms of their sales or the prices. So it's making our data to be not well represented. So it's up to you. You can choose to chop some data or to just take a subset of the data for you to come up with a more representative data from what you've actually loaded. So one way to do that, you can specify, for example, to say you are just looking for the data that is maybe below, maybe you want data that is below some points, like you can filter your data to say I want data or properties that are less than 1 million in terms of maybe their prices. So you are making sure that maybe the properties that you want to analyze are within the same range. And also you may want even to specify the type of the property. Maybe you want only houses. So let's see if we can have only houses and see what we could get. So let's filter here only houses. Filter only houses. So let's see that one. So we are filtering only houses, and this type indeed is showing only houses, and probably maybe the houses can have a better representation as compared to including just each. Okay, so it's much better as compared to the previous one. There are of course still outliers, but are not as many as before. And you can now even think of specifying the range. Maybe after that you would say, and we just want those that are above a certain houses that are above a certain maybe price range, or they are between a certain price range. Maybe price approx. Price approx USD, and we want only those that are above they're above 100,000, or maybe we should have only those that are below 100,000. Below 100,000. Sorry, that are below 100,000. So this one will give us only those that are below 100,000, but we still have very small here below 100,000, but it should be above something else as well. Okay, let me just put it as a separate filter. 100,000, then we want those that are maybe above 10,000. So because we have very small ones here, but they should be above 10,000. So we just want a certain segment of our data set, and we can have a better box plot for that. So with that data set, it means all of them are well represented. There is no outlier because we just took something. I've just done that, but in most cases, like what we are going to do later, the data set that we have for Mexico are for different states or different regions. So you can sometimes just want to zoom in for maybe for single region, or maybe for a single state, and just say I want properties for this state. Then you would want to see if there are outliers in that particular state, and you can do maybe a scatter plot for that particular state to see the trend, maybe for all properties or for a specific property like houses. Like in this case, we're using this small data set that we have, Of course, it's not well representative because we just filtered without space, considering important things, and our filtering has been across different regions because data is coming from different regions. But we may want to see if there is any correlation between the two, or maybe if there are some patterns between the two by plotting a scatter plot. So we jump all these things, but just come here and plot a scatter plot of this against this from our filtered data that we have done. So there are only houses that are above 100,000, are below 100,000 and above 10,000. So this is a scatter plot, and not very good, but it's showing that the trend is going towards the right. We are not having many properties that are less than 20,000, but with the square kilometers above 1,000 square meters, because there are those two properties we are tracking: the surface area and the approximate prices. So we can see that here we have a number of properties that are less than 20,000, and their areas are below. But we still have other properties that are very expensive, about 100,000, and they are also not covering very large space. So maybe around 200 square meters, but they are costing close to 100,000. So those houses are really very expensive. But this data is not well representing, or it's not giving us something very good, because it's for the whole country. So we might be having data for the from the cities and the other regions. Maybe other regions are richer as compared to other regions. So this data cannot be a well representative in terms of what we want to show. But at least we are able to use a scatter plot, and it's able to give us some analysis to say, okay, we have more plots. Some plots are expensive while they are smaller in terms of area size, but we have some plots that have got a very big area size but inexpensive, around 10,000, but they could go up to 600 square meters. So a very big house, but not expensive. But those ones are not many. But here we have others which are expensive and also big houses in terms of maybe floor area. So something like that. I hope we can stop here, and you would be able to continue experimenting with the little that has been presented here. Okay, as we are stopping, let me just run a histogram here. Yeah, so this is a histogram. With time, maybe let me not take more time from you, but you can also have a histogram to show or to visualize your data.